Okay, let's get into answering this question. So it looks like you're trying to guess the value of a limit. Guessing the value of a limit is a little bit different than what we might be used to normally with solving limits. So I'll just go over the basics really quickly before we begin. This is a limit as h approaches 0 of this function here. So we are trying to find the value of the function as this variable approaches the value 0. That's the value that we're looking for, or that's the value that we're going to try to guess today. What does that actually mean? Well, limits don't exactly tell us the function value at a given point. So let's talk about this function here. And maybe I'll sketch in some point up here. So this is kind of a wacky function, but it's a good example of a function where the actual value at x is equal to 0 is different than what the limit is at x is equal to 0. As we get closer and closer to 0, so if I put my pencil on the function and just trace it closer and closer to 0 on the left-hand side, we're going to get closer and closer and closer to, let's call that 1. We're going to get closer and closer and closer to 1. And on the right-hand side, the same way. I'll start a little bit far away from our point x is equal to 0. And then I'll just trace closer and closer and closer and closer. When I get to x is equal to 0, my y value is really, really close to 1 on this side as well. So our limit then would be equal to 1 here, but the actual function value might be something different. Maybe it's 2. Okay, so in this function, we're going to think about it in a similar way. In order to guess the limit for this function, we're going to try plugging in values of x, or in this case, h, that are closer and closer and closer to 0. Those values will get closer and closer to the y value, or the value of the function that our limit is at that point. So we're going to be able to find the limit by using this method. One way in order to do this quickly is using your calculator. I have a TI-84. Now there's 2 ways you could do this on the TI-84. There's the slow way and the fast way. We could press something like this. We could go ahead and enter in my function. So 4 plus, I'll do x for h. And so type in my function here, and then plug in whatever value I want to plug in for the first guess. And it looks like we're starting with 0.5. So if we start at 0.5, I'm going to, instead of writing x, I'm going to put 0.5 right in there. 0.5, 0.5. There we go. The other method of doing this is a little bit faster. I go into my y equals, I type in my function with the variable in it. So I'm going to do that same thing up here. Minus 64 over x. I'm going to go to second window and just double check my table settings are what I want them to be. I want them to look like this. Then I'm going to go to second graph, and I have an empty table to work with. Now these x values are the values that I'm going to be plugging in for that variable of my function. And we already have a list of values that this question wants us to plug in order to guess the limit. So let's go ahead and try putting some of those values in. Let me go ahead. Okay. So the first value, it looks like is 0.5. That's the same value that we got before in our calculator. The second one is 0.1. So that's a little bit closer to 0. Let's get it even a little bit closer. So let's try that next one. Even closer to 0, right? Even smaller of a decimal. Okay, we're getting 48. Let's do 0.001. 48 again. A little bit closer this time. And then let's try 0.0001. Okay, so even closer to 48. All right, and then the other half of doing this, so we took a look at what our function is looking like And let's pretend that this is our function, even though it's probably not what our function actually looks like. But what we just did is we started at, let's say this value is 0.5, and then we just plugged in x values that are closer and closer and closer to 0, and our y values got closer and closer and closer to a certain number. In this case, it looks like 48. So we did that for the positive side, and now in this question, it's asking us to do it for the negative side as well. So we're going to do the same thing. We're going to look at negative 0.5, and then get closer and closer and closer and see what value our y value here approaches. So I'm going to go ahead and do that now. We're going to plug in negative 0.5, negative 0.1, negative 0.01, negative 0.0, a mistake there, 0.001, negative 0.0001. Okay, and I think that's everything they wanted us to plug in here. It looks like we start with 42 something, 46 something, 47.88, 47.99, 47.9999. That's really close to 48. So it looks like the value that our function approaches here from this side is 48, and from this side is also 48. So our guess here is then going to be this limit is equal to 48 as our guess, just from being able to read the values of the function surrounding the point that we want to find. Why can't we just plug it in? Well, if we did plug in 0 for this function, something weird happens. We get, as h approaches 0, if we plug in 0 for h, we get 4 cubed, that's 64, minus 64, that's 0 on the top, and 0 on the bottom. So we can't have that. We can't have a 0 over 0 fraction at this point in our calculus career. So that is why we're going to look at this from both sides instead.